In this video, we are going to talk about the trigonometry of a general angle. So let us start this discussion with an arbitrary real number. For example, say our real number is negative 2.5. Is it possible to think of this real number as an angle and hence define the trigonometric ratios for this angle? So if someone asks you how much is the sine evaluated at the angle negative 2.5, how would you answer the question? So to get a perspective, we are going to first change this real number, which if you recall in our previous lectures we have referred to a radian measure. We'll change it to a degree measure. So first and foremost, we will understand negative 2.5 here in the context is in radian measure. And then we will go to our calculator and we will find the corresponding degree measure by multiplying 180 degree and dividing by pi. So clearly this angle is going to be a negative angle. So if I go there in my calculator, I do 2.5, change it to a negative number. And then as I said, we multiply 180 and we divide by pi. So rounding it to 4 decimal places, I get negative 143.2394. So this is negative 143.2394 degrees. Then we're going to draw this angle in the standard position. And again, remember, this is a negative angle, so we're going to take the clockwise rotation. The initial side of the angle in the standard position will be coincident with the positive direction of the x-axis. And if I complete 90 degree, I need to do minus 63.2394 degrees more. So that's a little less than 90 degree. So something along this line is the terminal side. And this is the direction of the angle. So this angle that we have drawn is negative 143.2394 degrees. So now our question is whether we can find the trigonometric ratios, the sine, cosine, tangent, cosecant, secant, and cotangent for this angle. One of the nicest way to find the trigonometric ratios is to think about the circle centered at the origin that has the radius of 1 unit. So let's let this is the circle that is centered at the origin and it has a radius of 1 unit. And then we look at the terminal side of our angle, which is this one, that is going to cross the circle at a point. And this point of intersection between the terminal side of the angle and the unit circle, so this circle of radius 1, so let me say the center of this circle is 0, 0, the origin, and the radius is 1. And in future, we're going to refer to this circle by saying the word unit for one circle. And it will be understood that this circle is always at the center, centered at 0, 0. So this point of intersection is our reference point. With respect to this point and the two sides of the angle, there is a way to find the trigonometric ratios for this particular angle. So the process is, at this point, you are going to draw a perpendicular line that starts at this point and goes to the x-axis. So for example, I will drop this line, and this is the perpendicular line, and I will just consider this much of the angle here, which, if you remember, is the reference angle. So the reference angle this time is going to be 180 degree minus 143.2394 degrees, which is equal to, so I get 0.6, so let me write it a little better way. So I get 6 0. When I do the subtraction, I get 6. I get 7 point, and then 9 minus 3 is 6. 7 minus 4 is 3. So this is 36.7606 degrees. So what I do now, I draw this reference angle in the standard position. Instead of working with the actual given angle, we draw the reference angle in the standard position. And that is going to be 36 degrees. It should be in the first quadrant. So let's say this is the angle, 36.7606 degrees. And again, we think about the unit circle. So say this is my unit circle. Think about the point of intersection and draw a perpendicular line as you have done in the previous situation. And then think about this triangle that we are seeing here, that I'm making in bold, as the right angle triangle, and hence define the trigonometric ratios for this triangle. The only other thing that we will do after we have defined the trigonometric ratios is the sign manipulation, which we will talk a little later. So this is one way of understanding the trigonometric ratios of a given number, a real number given, considering that as an angle. If I have to find the trigonometric ratios, I can adapt this process of using the reference angle to find the trigonometric ratios and then finding the sign manipulations. Or we can actually work with the actual given angle, and for this actual given angle, we can start finding the trigonometric ratios. So what we will do now, we will adopt a general procedure for finding the trigonometric ratios of a given real number using circles. So far we have worked with unit circle, but that doesn't have to be unit circle. Using unit circle makes our work easier, but it can be a circle of any radius. So in order to establish this idea, we are going to start with arbitrary points. For example, say we are starting with a point in the first quadrant, so this point over here, and it is of coordinates 3, 4. I do drop a perpendicular line from this point on the x-axis and join this point with the center, and think of a circle that has the radius equal to the hypotenuse of this newly formed right angle triangle. So given this point, it is not difficult to find out the length of the hypotenuse. As you can imagine, the height of this triangle is 4 units. So I'm going to call it 4. The base is 3 units. If you use the Pythagorean theorem, then you would find out the hypotenuse, so which is this side here. Generally, I'm going to call it r to remind myself this is radius of the circle that has the same length of the hypotenuse. So r, by Pythagorean theorem, is the square root of 3 square plus 4 square, which is equal to square root of 9 plus 16, and that is square root of 25, which is equal to 5 units. So once I have this information, I can use the trigonometric ratios for a right angle triangle to talk about the trigonometric ratio corresponding to the point 3, 4. In that situation, the angle that we are associating it with is this. So what are the trigonometric ratios? So we will say sine of theta, if we remember the definition, this is opposite over hypotenuse. So remember, this is the reference angle theta. So the opposite side is 4 and the adjacent side is 3. So sine of theta is going to be 3 over 5. Cosine of theta is going to be adjacent. Sine of theta will be 4 over 5. My mistake, because the opposite side is 4 units long. Cosine of theta is the adjacent, so 3 over 5. Tangent of theta is the opposite over the adjacent side, which is 3 units. Cosecant of theta is the reciprocal of sine theta, so that's 5 over 4. secant of theta is the reciprocal of cosine theta, that's 5 over 3. And cotangent of theta is the reciprocal of tangent theta, so that's 3 over 4. So as we have talked about, these are the trigonometric ratios that are associated with the point 3, 4 on our Cartesian coordinate system. Now, as you can imagine, we can do the same work for a point that is situated in the second quadrant. For example, if you have a point, say here, and you want to say this point, first of all, say this point is equal to 3, 1, because x is negative, I have to say negative 3, 1 are the coordinates of this point. And if I want to know what are the trigonometric ratios associated with this point, I have to first tell myself that the angle associated to this problem is having the standard position and the initial side coincident with the positive direction of the x-axis. So what the angle we are talking about has this as the initial side and this as the terminal side. So this is the angle theta. In order to find out the trigonometric ratios for this angle, what you can always do, you can adopt the same process that we have adopted for the point in the first quadrant. So we are going to go ahead and from the point, we will drop a perpendicular line on the x-axis. And we are going to say this is our reference angle. And when we are working it out, we're going to say that the height of this triangle is 1 unit and the base is negative 3 units. So if I'm trying to find out the trigonometric ratios, I have to say now that sine of theta, which is opposite over the hypotenuse, so I need to know the hypotenuse first, is going to be the square root. So again, you can think of the hypotenuse given by the radius r, and then r will be equal to the square root of the two sides square. So you do negative 3 square plus 1 square, and that is equal to square root of 9 plus 1, which is square root of 10 units. So hypotenuse is square root of 10 units. So sine theta is going to be the opposite side, which is 1 over square root of 10 units. Cosine theta is going to be adjacent negative 3 over square root of 10 units. And similarly, we will say tangent theta is opposite over adjacent, and that is going to be opposite side is 1 and the adjacent side is negative 3. So this one is actually a negative value, so it's negative 1/3. And then you can do the reciprocal for the rest of the trigonometric ratios. For example, now I can say that cosecant of theta is equal to square root of 10 over 1, so square root of 10. Secant theta is also negative, and that's a reciprocal of negative 3 over square root of 10, so that's square root of 10 over negative 3, so I can say the minus in front. And finally, cotangent theta should be negative as well. So cotangent of theta is equal to negative 3 over 1, so negative 3. So what is the difference between a point and the corresponding trigonometric ratios in the first quadrant versus a point in the second quadrant and their trigonometric ratios? See, when the point was in the first quadrant, all 6 of the trigonometric ratios were positive trigonometric ratios. Whereas when your point is in the second quadrant, only the sine and the cosecant values are positive, and the rest of the 4 trigonometric ratios are negative. So what I will show now, what happens if the point with respect to which I'm trying to find out the trigonometric ratios is in third and or fourth quadrants. So let us start with a point that is situated in the third quadrant this time. So let's say the point is the point Remember, this time both x and y are negative, so negative 2 comma negative 3. That means if I drop this perpendicular line and connect this point with the center, this line is the radius of the circle or the terminal side of the angle, and the initial side is coincident with the positive direction of the x-axis, and the angle for which we are trying to find the trigonometric ratio is going to be this one. Remember, the base of the triangle is of the length negative 2 units and the height is negative 3 units. So this is our setup, and we're going to find out the radius or the hypotenuse of the triangle. So it is going to be radius equal to square root of, so I will get negative 2 square plus negative 3 square. These are the two sides of the triangle. So that is square root of 4 plus 9, and that is square root of 13. So when I'm finding the trigonometric ratios, sine theta, now this is the reference angle, this situation. So with respect to this angle, the opposite side is negative 3 and the adjacent side is negative 2. So sine of theta is going to be the opposite over the hypotenuse, the opposite being negative 3, I get negative 3 over square root of 13. Cosine of theta is going to be adjacent, so negative 2 over square root of 13. Tangent of theta is going to be opposite, so negative 3 over negative 2, and that's 3/2. So this time I find that my tangent is actually positive even though the sine and cosine are negative. And then cosecant is reciprocal of sine, so you can say this is negative square root of 13 over 3. Secant theta is the reciprocal of cosine, so that's negative square root of 13 over 2. Cotangent theta is the reciprocal of tangent theta, which is 2/3. So again, in third quadrant, if the point is in the third quadrant, that means the angle's terminal side is in the third quadrant. We see that sine, cosine, secant, cosecant, those four trigonometric ratios are negative, whereas tangent and cotangent are positive. So the last thing that we will do is the trigonometric ratio for a point or corresponding to a point that is in the fourth quadrant. Now anything that is in the fourth quadrant will have the x coordinate positive but the y coordinate negative. So let's say here is my point, and this point has the coordinate of say 4 comma negative 2. So as usual, we're going to draw the angle in the standard position. So initial side is coincident with the positive direction of the x-axis. Terminal side is the radius joining the point with the center. We're going to complete the triangle by dropping the perpendicular line on the x-axis. So the angle in question is this angle, and that is your theta for which you are trying to find out the trigonometric ratio, and this is the reference angle. So the base is of length 4 units, height is of length negative 2 units. We're going to find the hypotenuse. So hypotenuse is going to be square root of 4 square plus negative 2 square, which is square root of 16 plus 4, and that is square root of 20 units. So when I'm trying to find out the trigonometric ratios for this particular situation, with respect to the reference angle, negative 2 is the opposite side and 4 is the adjacent side. So I will go ahead and say sine of theta is opposite, so negative 2 over square root of 20, that's the hypotenuse. Cosine of theta is adjacent, so 4 over square root of 20. Tangent of theta is opposite over adjacent, so 4, and that is, you can say it is negative 1/2 after simplification. Cosecant of theta is going to be the reciprocals, so minus square root of 20 over 2. Secant of theta, so I should say this is cosecant of theta, and then secant of theta is square root of 20 over 4. Finally, the cotangent of theta is -2. That's the reciprocal of -1/2. So what are the information we have obtained so far? Depending on which quadrant we are working on, the signs, the positivity, negativity of the trigonometric ratios are going to vary. So we'll adopt a general rule, and we will remember this rule this way. In the first quadrant, all trigonometric ratios are positive. Doesn't matter whether I am doing sine, cosine, tangent, cosecant, secant, or cotangent. In the second quadrant, only sines and cosecants are positive and everything else is negative. In the third quadrant, only tangent and cotangent are positive and everything else, the other four trigonometric ratios, are negative. In the fourth quadrant, both cosine and secant are positive and the other four trigonometric ratios are negative. So if we remember this simple fact, along with this simple fact and with the fact of reference angle and what I have shown you at the beginning of this lecture, how to use a reference angle to find out the trigonometric ratio for any given number in the context of an angle, we can very easily find out trigonometric ratios for any real number when considered as an angle. Now, one other fun fact here that we will work out, and then we will go start solving our problems in this section. What happens if the radius of this circle is 1? Remember, I told you that if you take the unit circle or the circle of radius 1, your calculations become way easier. So think about the point in the first quadrant, which is 1/2, comma, square root of 3 over 2. So these are the coordinates of the point. So say this is the point. Then I do the same thing. I join the point with the center and I call it the terminal side of the angle. The initial side of the angle clearly is going to be the side that is coincident with the positive direction of the x-axis. And the angle theta is this one. So as usual, we're going to find out the hypotenuse. Remember, this time the height is square root of 3 over 2 units and the base is 1/2 units. So r is going to be square root of 1/2 square plus square root of 3 over 2 square. So I can say that this is square root of 1/4 plus 3/4. When I add them, I get square root of 1, and that is equal to 1. So if you find sine theta, then that is going to be the opposite side, square root of 3 over 2 over 1, which is itself square root of 3 over 2. Similarly, cosine theta is just going to be 1/2 because I'm dividing by 1. The tangent theta value is going to be square root of theta 3 over 2 over 1/2, which when you cancel the two 2's, you get square root of 3, and so on. So that means if I now look at these things a little carefully, remember square root of 3 over 2 was just the y, 1/2 was the x. So what I found out for a unit circle, and this is a very crucial information, for a unit circle, if the radius is 1, the fun is I actually do not care about the hypotenuse anymore. I just go ahead and say that whatever the point we are dealing with, sine theta is just the y coordinate of that point. Cosine theta is simply the x coordinate of the point. Tangent theta is y over x. Secant theta, or let's first do cosecant. So cosecant theta is the reciprocal of sine, so it's 1 over y. Secant theta is the reciprocal of x, so that's 1 over x. Cotangent theta is x over y, the reciprocal of tangent theta. So these are all the information, the primary information that we wanted to know before we start talking about our lecture note. And let's go ahead and have the lecture note ready for us, and we will work on it and solve some problems that will help us do the homework problems, of course. So let's see. So this is the lecture note that we will work on now, and this is about the trigonometric functions of any angle. So we have kind of the description that we talked about. So I'm going to skip these descriptions and the formulas that we have written down so far, and we're going to start working with our problems. So every single time I give you a point and I say that this is on the terminal side of theta, find each of the 6 trigonometric function. And you are going to start the problem by drawing the angle in the standard position. Okay, so this point is negative 6 comma 8. So x negative y positive means I am in the second quadrant. So this is my point. Remember what I did, I formed a right angle triangle and I called the x as the base, y as the height, and this is the r, which we're going to find now. So we will call the angle in the standard position. So there is a little bit of intuitive understanding here. So the actual angle that I'm finding the trigonometric ratio is in the standard position, and this is the angle theta. But to find that trigonometric ratio, we are using the reference angle right here. Okay, so r is square root of negative 6 squared plus 8 squared, which is square root of 36 plus 64, and that's square root of 100. So that is equal to 10 units. So now I do what? I say then sine of theta is the opposite side 8 over the hypotenuse 10, and I can simplify that as 4 over 5. Cosine of theta is the adjacent side, negative 6 over 10, simplify that as negative 3 over 5. Tangent of theta is opposite over adjacent, simplify that as negative 4/3. And then you just do the reciprocals. So cosecant of theta for this angle is going to be 5 over 4. Secant of theta is going to be 5 over negative 3. Cotangent of theta for this angle is going to be negative 3 over 4. And that answers my question. Let's do one more example of this kind. This time we are going to find the trigonometric ratios for the angle that has the terminal side with the point 12 comma negative 12. So x is positive, y is negative. That means we are in the fourth quadrant. So we'll get that point first. Draw our little right angle triangle. So say this is the point and call it 12 comma negative 12. And I'm going to complete the right angle triangle. So the angle has the initial side coincident with the positive direction of the x-axis, and the terminal side is this one with the point 12 comma negative 12. So this is the angle for which we're finding the trigonometric ratios. But again, remember, we are just using this reference angle to work it out. So base is 12, height is negative 12, and you are interested in finding the hypotenuse. So the radius is going to be equal to square root of 12 square plus negative 12 square. And both of them are 144. So I get a total of 288. And then if you want, you can simplify this thing as, you can write this thing as 12 square root of 2. That just looks better. So what I do with this now, I'm going to find the trigonometric ratios. So sine theta is opposite, and opposite is negative 12 in this situation, over 12 square root of 2, which is negative 1 over square root of 2. And remember, rationalizing will give you negative square root of 2 over 2. That's one way of writing it. Cosine theta is going to be adjacent, which is 12 over 12 square root of 2. So this is positive 1 over square root of 2. And that one you can write after rationalizing as square root of 2 over 2. Tangent of theta is going to be negative 12. That's the opposite side over adjacent 12. So that is just negative 1. And then the reciprocals. So cosecant of theta is going to be negative square root of 2. Secant of theta is going to be square root of 2. And cotangent of theta is a reciprocal of negative 1. So that's 1 over negative 1, which is also negative 1. So that should be pretty simple for us to work out. The quadrant angles that we have talked about has special trigonometric values, and you can just think about these quadrant angles based on the unit circle. So let's talk about that real quick. So think about, I'm trying to find out the trigonometric ratio sine, cosine, and tangent for the angle 0 degree. So this is the initial side, this is the terminal side as well. If I consider a point on the unit circle, so the radius here is 1 unit, then the coordinate of this point is going to be 1, 0 because it is on the unit circle. So x is 1, y is 0. So then sine theta is going to be, remember it is y, so 0. Cosine theta is simply x on the unit circle, so that's 1. Tangent theta is y over x, so that's 0 over 1, and that's 0. And this is what we have in this list. Now, if I wanted to know the trigonometric ratios for 90 degrees or pi over 2, then the initial side remains the same. The terminal side is here. On the unit circle, the coordinate of the point is 0, 1. So now, if theta was 0 degree, we have seen what are the trigonometric ratios. And now we are going to do it for 90 degree or pi over 2. So let's just write pi over 2 for fun. So we'll say sine of pi over 2. Remember, this is going to be the y coordinate, which is 1. Cosine of pi over 2 is the x coordinate, so that's 0. Tangent of pi over 2, whereas, is going to be 1 over 0. It's y over x, so that is undefined. And now if you go back to the table that I have given you, these are exactly the values that we have obtained. So let's do the reference, the quadrant angle 180 degree or pi. So this is your new terminal side now. So that is the angle. And this point on the unit circle will have the coordinates of -1, 0. So what is sine of pi or sine of 180 degree? Well, that's the y value, which is 0. Cosine of pi is the x value, which is -1. Tangent of pi is y over x, so that's 0 over -1. And that is equal to 0, which is exactly matching with our table values. And finally, we do the quadrant angle 270 degrees, which is here. That's the terminal side. Initial side is still the same. And this time the point on the unit circle will have the coordinates of 0, -1. These are the coordinates. So sine of 3 pi over 2, which is 270 degrees, will be the y coordinate of -1. Cosine of 3 pi over 2 will be the x coordinate, so that's 0. Tangent of 3 pi over 2 will be equal to -1 over 0, and that is undefined as well, which is matching with the table values. So if the question now asks you how much is cotangent of pi, well, think about how much was tangent of pi. Tangent of pi was equal to 0, so cotangent of pi is going to be the reciprocal of that, so that will be 1 over 0. So this is going to be undefined. And this is how you can find the cosecant, secant, and the cotangent values for the quadrant angle just by taking the reciprocal. All right, so let's carry on. So the following examples are going to give you some conditions, and depending on these conditions, we're going to find out the remaining of the trigonometric values. So the first one is, let theta be an angle in the standard position. Name the quadrant in which theta lies. So I'm just going to say in which quadrant I should be. So sine of theta is less than 0, so that's negative. Tangent of theta is less than 0, that's negative. And remember, sine and tangent negative means cosine is positive. And cosine is positive only in the fourth quadrant. So I'm going to go ahead and say that theta is in the fourth quadrant. And this is going to help us do similar problems. In fact, even finding out the trigonometric ratios for the remaining trigonometric values. So theta is in the fourth quadrant. So let's carry on. Next question says that sine of theta is 4 over 5 and you are in the second quadrant. So this is what we're going to do. It's 4 over 5, second quadrant. So first you choose a point in the second quadrant. Call it the terminal side. Call this one the initial side. And then this is the theta. And this point will have the coordinate of something comma 5. So I want to find the coordinates. Remember, what is 4? 4 is the opposite side. So if I know that much, then I will be able to say that this is 4, this is 5. This one I actually do not know yet. So how to find that out? So remember, this is the x coordinate. So I can now call it the x value and say x square plus 4 square should be equal to 5 square. That's Pythagorean theorem. So x square plus 16 is 25. That means x square is 25 minus 16, which is 9. So I take the square root on both sides. I get absolute value of x is equal to 3. Remember, that gives you two solutions. It gives you x equal to 3 or x equal to negative 3. Which solution I choose? Well, clearly I choose x equal to negative 3. How come? Your point is in the second quadrant. Your x is negative. So this point is 4 comma negative 3. And that is going to help us find all the trigonometric ratios. So sine theta is 4 over 5. And I want to find out the remaining trigonometric ratios. So we'll go ahead and say cosine theta, which is adjacent. So adjacent this time we found out is negative 3 over 5. Tangent of theta is opposite over adjacent, so that's 4 over negative 3. And then the reciprocals, cosecant of theta is going to be 5 over 4, reciprocal of sine. Secant of theta is the reciprocal of cosine, so that's negative 5/3. And cotangent of theta is the reciprocal of tangent, so that's negative 3/4. That answers my question. Find the exact value of each of the remaining trigonometric function of theta. So this time I did not tell you what quadrant you are in. Let's see what you have. You have tangent positive. You have secant positive as well. Secant is 5 over 4. Tangent is positive. In which quadrant both secant and tangent are positive? The only option for both secant and tangent to be positive is the first quadrant. So first we say theta is in the first quadrant. And then we draw our little triangle. So we have this situation. As the point is in the first quadrant, we can go ahead and say that this is the point. Now secant theta 5 over 4 already tells you cosine theta equal to 4 over 5. And I do it because I want to know the sine, cosine, or tangent ratio in order to help us draw the triangle. So cosine is x, adjacent value. So this side of the triangle, when I complete it, is going to be referring to the angle with this one as the initial side, this one as the terminal side, and this is my angle theta. And this side is 4 units. That's the adjacent side. Hypotenuse is 5. We're going to find out the y coordinate. So this time 4 square plus y square is equal to 5 square. Similar calculation as of the last one. So y square is 25 minus 16. So y is, or actually say y square equal to 9. Take square root. Do not forget your absolute value equal to 3. Two solutions. Y is 3 or y is negative 3. This time I choose y equal to positive 3 because I'm in the first quadrant. So the point that I'm interested in is 4 comma 3. And then it is going to help me do the trigonometric ratio. So sine of theta is going to be opposite. So 3 over 5. Cosine theta we have already found. 4 over 5. Tangent theta should be 3 over 4. That's opposite over adjacent. Cosecant theta is the reciprocal of sine, so that's 5/3. Secant theta is given to us. It's also the reciprocal of cosine, so that's 5 over 4. Cotangent of theta is 4/3. And we are done with this problem. A different way of seeing a similar problem. So this time cosine is positive, and you know that your theta is between 270 degrees and 360 degrees. So think about that. 270 degrees and 360 degrees must be in the fourth quadrant. So the point is here. Again, I'm given with cosine, so let's complete this triangle. Cosine means you are given with the adjacent side, so this is 15. And the hypotenuse is 7 units. So you are going to be finding out the opposite side or the y value. So what I do, I say this angle is my angle that we will work with. and that is the theta value. And I do the Pythagorean theorem where I say 15 square plus y square is equal to 17 square. So 225 plus y square is equal to 289. I subtract 225 from both sides. So I get 289 minus 225, which is 64. So y, if I take the square root on both sides, is going to be absolute value of y equal to 8. So y is either equal to positive 8 or it is equal to negative 8. Which one I choose? Well, I choose y equal to negative 8. And why do I choose y equal to negative 8 in this situation? Because you are in the fourth quadrant, so your y value must be negative 8. So now I get to say that this point that I was looking at is the point 15 comma negative 8. And then we start with the trigonometric ratios. So sine of theta is the opposite side, so negative 8 over 17. Cosine of theta is given to us 15 over 17. Tangent of theta is opposite negative 8 over adjacent 15. Now you do the reciprocal, so cosecant of theta is negative 17 over 8. Secant of theta is equal to the reciprocal of cosine, that's 17 over 15. And finally, cotangent of theta is the reciprocal of tangent theta, which is negative 15 over 8. This last question is going to talk about the unit circle and transformation of different kinds. So P of t is cosine t comma sine t, has coordinates 0.316 comma 0.949. Find the coordinates of P t plus pi. So see what I do. In every single situation, we're going to draw a little picture of the unit circle and understand this point. Since both x coordinate and y coordinates for t are positive, I know that this point must be in the first quadrant. So this is my t. If I do t plus pi, so I need to start here. This is the t. T plus pi should be on the opposite side, so it should be here. So this is t plus pi. For this point, what will be the coordinate? Well, in third quadrant, both x and y are negative. So what is your x? Whatever x was given to you, you just take their negative value. So you say minus 0.316 and minus 0.949 answers your question. For the second one, it is p of negative t. So again, t is in the first quadrant because both x and y for t are positive. Negative t is going to be, so if this is t, that's a positive t, the negative t will be the clockwise direction, so that should be the same measure of the angle, just in the clockwise direction. So this should be my negative t. But negative t is in the fourth quadrant, so x is positive, so I'm going to go ahead and say that this is 0.316, but y is negative, so that's minus 0.949. T minus pi is my third reference. So t, as usual, is in the first quadrant. Minus pi should be in the opposite direction to the t in the clockwise direction. So this is t minus pi. But see, that's still in the third quadrant, so both your values for x and y are negative. So I'm going to go ahead and say that this is negative 0.316 and negative 0.949. The fourth one is negative t comma negative pi. So I'm going to do it twofold. First and foremost, let's start with t. That's in the first quadrant. Negative t. So if this is the positive t, then I do the same measure. I get my negative t somewhere here. And then I do negative t minus pi. So I need to do pi more in the clockwise direction. So that will give me the opposite direction. So this is negative t minus pi. Because this is pi units, negative pi units in the negative direction. So now we are in the second quadrant where x is negative, y is positive. So you get minus 0.316 for x and 0.949 for the y value. So that kind of sums up all the things that we wanted to talk about in our today's lecture. Keep working on your homeworks. Let me know if you have any question. Next time, we're going to start a little more generalization of the trigonometric ratios for a real number.